Right. Hacking for the Fin, 2017. So this mic actually is not for projection in the room. This is only for recording purposes. So that's one thing I wanted to do as a quick piece of housekeeping. You guys are going to be given these handheld mics, so those who are tuning in from live stream can hear you all. Not necessary for folks in the room, so be conscientious of that. Secondly, you all know the order of presentations today. So before your team, once your team is in the queue, please make your way to the right stage left of the room so that it's a smooth transition between teams, all right? I think that's all I really need to cover today. Okay.
Thanks, Isaac. For those of you who've suffered through the class for 10 weeks, you know me. But for those of you who are guests, I'm Steve Blank. Let me introduce the teaching team, Joe Felter, Steve Weinstein, Pete Newell. Did I leave anybody out? And our TAs? Where are our TAs? Yeah? Who actually made the trains run on time. Today's lessons learned presentations are going to be pretty simple. Each team is going to show you a 2-minute video and then an 8-minute PowerPoint presentation. I'll discuss briefly what they're trying to show you today. But I thought first, I see a lot of guests in the room. We usually go around and have the guests just raise their hand, stand up, and one sentence, who you are. Let's start over here. Any guests? Yep.
I'm Michael. I'm the roommate of Ostrum.
Great. All right.
Hello, Lieutenant Colonel Donnie Hazeltine with 23rd Marines, and I worked with Explomo, Surgency, and quite a few touch points with Ostrum and security and VA companions.
Whoa. Thank you. Great. What department?
Rhetoric.
Great.
John Yee with the Travis Air Force Base. These guys too. We just came down here as a part of the program that we're part of. So.
Kevin Uniac, Travis Air Force Base. Gary Costa, Travis Air Force Base.
Yes, sir. Joey Brewer, Travis Air Force Base. So all of us are pilots and intel officers and different stuff.
Did you bring a U2 with you? I mean.
Chuck Wolf, I'm a senior advisor with BMNT, and we're looking at the urban resiliency development piece.
From Single Valley University.
Dan Coster, I'm the operations officer for Navy Special Warfare Center, working with 21st Century Frogman.
Okay. Back over here.
Okay. I'm Sheila Davis. I'm from the VA Palo Alto. I'm the first of a big bunch of physicians and providers and awesome people from the VA.
Is that the whole VA team? All right.
So far.
All right. All right.
I'm Bossy Dede. I'm one of the head surgeons at the school.
Steve Hong, I'm one of the mentors for the best team on earth. The best.
Mayor Holiday, Grand Corporation. Mentored whoever you need.
No. What did you used to do, Maynard?
Okay. I was the senior technical advisor of the Undersecretary of Defense for acquisitions.
Aha.
Craig Spedell, mentor for Broadcom.
Peter Higgins, been mentoring security.
Gloria, head of Navy and Monica, also hacking for diplomacy last quarter.
Okay, same thing, hacking for diplomacy, same people.
Next.
Michael Kennedy. Zogging course. Tom Byers, I'm professor of management science and engineering, just trying to keep the teaching team happy.
All right. We all work for Tom.
Hi, I'm Marta Hoffman, and I watched this on Blue Jeans last year and thought it was great, so I'm here this year to Wallace. I'm with Cadium, and I've been advising Frogman and a couple of other ones.
Daniel Barnstein with Exidine. I'm a mentor for Ostrum.
Who's next?
Hi there, I'm Laura Flores. I'm a partner at Inducing Horowitz, and I help our portfolio companies establish meaningful business relationships with the government.
Hi, I'm Tom Bettertray. I'm a Stanford DCI fellow, and I'm a mentor for a team that I can't disclose.
I'm Donna Slade. I'm mentor for VA Companion. I'm also a DCI fellow.
Thank you.
And I'm Elliot Slade, a DCI fellow, and I'm hooked to her.
Dave Jaffe, lecturer in mechanical engineering.
Rick Woolworth, DCI fellow.
Anybody else we missed?
Super Leland, DCI fellow, heard it was the best class of the year.
Mark Nelson, attorney at law, member of Donna Slade's fan club.
Let's go.
Colonel Mike Turley, I'm a Hoover National Security First Fellow, mentor with the VA Companion.
Anybody I miss on this side? No. All right. Let's go here.
Housemate of other best team in the room. Free, Kelsey, Jerry, Andy. We met the other day. Good to see you. Thank you for showing up your friend the same team.
Modi also from that team.
Brad also.
Did you bring pom-poms or something for the
Josh King, Masters in Computer Science student here.
Roy Chabadi, founder and CEO of Stellar AI and mentor of security.
Ian Cinnamon, we're applying computer vision to TSA baggage day.
Drew Gorham, I'm a product manager at BMT. I work with Beat.
Jason Rathke, first year MSc PhD student, just helping the team with procurement related questions.
Jeff Decker, researcher at CSEC here at Stanford. Frogman, I do something at Stanford.
William Traceder, fanboy of Pete Newell.
Anybody else?
John Brick, also designer at BMT.
Deborah Gordon, I'm responsible for the 4.
We'll tell that story.
We will. Anybody else? Who haven't we? Yes.
Davis, BMT partner.
Great. Do we leave anybody out?
Technical Rich Lawson, Chief Operations Test Director for the Marine Corps, Marine Aviation, Science Technology Director.
Great. Well, thank you, all the guests, for showing up and all the moral support. And now, teams, no pressure at all. What I thought we'd do for the guests is just to remind them in about 3 slides what today is about. The class was essentially to do a couple things. Have the teams learn about the nation's threats and security challenges while working with sponsors inside the Department of Defense and intelligence community. And a second goal was to teach students entrepreneurship while they engage in a national public service. Obviously, every one of our students has the opportunity here to go to work for Google or Facebook or any other hot startup of the week here. But very few teams ever get to engage with equally interesting but more strategically important problems that the country faces. And I think every one of these students has worked on, I think, technically challenging but hopefully fulfilling problems. This is not a demo day. Anybody ever sat through a demo day presentation? This is not it. A demo day presentation is essentially, a beauty contest in bikinis of engineers, which is just like, it boggles your mind to think about that. But a demo day is how smart is the team at any instant in front of you. And we think that's just not right. Teams don't get smart the minute they hit the stage. Particularly teams in this class have gotten smart by 10 weeks of excruciatingly painful learning. And so what the class is about is a summary of what the team learned in 10 weeks, and then they'll tell you how smart they are at the end. But we think the journey is really an important part of what makes the lean methodology and this process so exciting and interesting. And it's a summary of also what their sponsors learned in 10 weeks. And again, we use the lean startup methodology in this class. It basically has just 3 components. One is the teams framed all their hypotheses. They got a problem from the sponsor, and they deconstructed that problem and put it on something called the mission model canvas. Who are the beneficiaries, the stakeholders, what should they build for them, how are we going to deploy, how do we get buy-in, how do we measure mission achievement, what are the key activities, what resources do we need, what partners do we need, and what kind of costs. But instead of just writing that down and calling it a day, all the teams started with that these are nothing more than a series of untested hypotheses. And the whole rationale about the class is, thanks for having those hypotheses, now get out of the building and test them. And that should not have 2 C's at the end. But it's basically get out of the building, test hypotheses, and do so by talking to over 100 customers, partners, sponsors, warfighters, regulators, legal, security, and whatever, 10 a week while taking a full course load. And by the way, while you're doing that, build the product incrementally and iteratively so we have what we call minimum viable products. Not finished products or services, but enough testing with real screenshots or core source code or prototype hardware to see whether our hypotheses were correct. The goal of the class is not to deliver products or services, but to test hypotheses. And what you're going to see is the journey that these teams have gone on, starting with their initial understanding of a sponsor's problem, what they thought they were going to be building on week 1, and where they ended up and how they got there in 10 weeks. So with that, I think our first team.
Yes.
All right.
Oh, you want to tell the format? Just so you know, there's going to be 4 teams and then a break and 4 teams.
All right, everybody hear that? 4 teams, break, 4 teams. And the best teams, you'll have to figure out when.
Thanks, Steve. Okay, so first team up is Team Frogman. Every team is going to have a video that kind of gives you a bit of background on their problem, and then they'll go into the actual lessons learned presentation.
Naval Special Warfare Center is the Navy's training ground of the elite sea, air, and land commandos known as SEALs. The first 7 weeks of SEAL training, known as First Phase, test SEAL candidates physically and mentally with a variety of challenges to find those best suited for selection. Candidates work together in boat crews in water and on land. Surf passage, ocean swims, the obstacle course, and repeated physical exercise test every candidate to their limit. Professionally trained SEAL instructors ensure that the center remains a learning organization with a mission of selecting candidates for dedication to the team and country who exemplify competence. They serve as the mentors for the next generation of America's special operators. But instructors have a pain point that detracts from their effectiveness. Each day they collect an immense amount of data on up to 200 students during every training evolution. This data is recorded by hand into notebooks during training. Following the evolution, instructors must input the data from their notebooks into an outdated database with a painfully clunky UI. On average, this process takes 9 minutes per comment. This cumulatively wastes days of valuable instructor time for each class.
Enter Team 21st Century Frogman. Armed with data analytics and the lean methodology, we brought proven strategies from the Silicon Valley to address the instructor's pain point. Yet how could we truly understand our customer from inside the Stanford bubble? We realized we had to get out of the building and into the wet, soggy boots of our customers. So we flew down to Coronado, California, toured the facilities and interviewed instructors, students, and center leadership. But that wasn't enough. We said we wanted more, and the instructors happily obliged. With a newfound deep understanding of our beneficiary, we moved forward with developing an app for instructor data entry. Our solution is a one-stop shop for the instructors to enter data, take notes during training, and submit reports in real time. The data collected via our app can be used to better inform training in the future.
Same as the class.
Yeah.
So.
Did y'all enjoy my wonderful push-up form? Phenomenal. But yeah, while he's getting set up, like we mentioned, we are Team 21st Century Frogman. Yeah, for sure.
Remember, the microphones are for not projection, but for recording. Right.
We are Team 21st Century Frogman, and we had the great honor of working with the Navy SEALs, the Naval Special Warfare Center, in their training. Our sponsor is here right now, so I do want to acknowledge how instrumental he was to our success and also our failure at push-ups, because that would not have been possible without his support. And so just so you saw in the video, right, we actually had this great idea with our apps, but we didn't start there. What you didn't see in the video is we actually started with data analytics and predictive analytics for injury prevention. But over the course of this course, over 100 interviews, we found that the actual problem we needed to be solving was data entry, the data entry burden for instructors. And so what we're going to do today is tell you the story of how we got from there to where we are now. Like any great story, we have a great cast of characters. There are 3 engineers and an MBA, and of course, our phenomenal sponsors. So a couple of you are in the room here today, and again, we cannot thank you enough for all the interviews you helped us arrange. The interviews consisted mostly of active duty military. We also talked to civilian military and industry experts, which led to a grand total of more interviews than have ever been conducted for this problem in the history of time. And what happened over the course of these interviews was actually a phenomenally an emotional roller coaster. We have a couple highlights here that we're going to discuss in our presentation. But you can zoom in on any one of these days and see even more drama. For example, during our visit to the center, you'll see there's a huge drop in team morale at about 7 p.m., which corresponds to roughly about the same time we jumped into the Pacific Ocean. Andy was fine, but the engineering team was struggling. To jump right in, we could talk about this for days, but our first main challenge, the first path we went down, was database integration. So with injury prevention, we have to look at data. So our first interviews consisted of drawing a data flow diagram of all the information in the center, and we found that there were 9 databases in use that we'd have to work with. So when we talked to people, we said, what data analytics do you currently have in place? And the answer was, well, we mostly just use Control-F. And that led us to understand that there was a huge issue here and a huge opportunity that we thought we were going to capitalize on when we went there. Perfect, problem solved, right? Give us our A+ now? Of course not. We went down to the center, and we got to spend a day in the life of our customers, as you saw. But one thing we learned really quickly is when your customers are Navy SEALs, it turns out that day is actually quite painful.
So besides just learning about the problems of our sponsor, another great aspect of getting out of the building is it taught us just how wrong we were about our primary beneficiaries. So when we started this problem, again, we were focused on injuries and reducing injuries. So we naturally thought that the medical officers and doctors at the center and the students, the BUD students, would be our primary and secondary beneficiaries. But once we actually dove into it, started talking to everyone down there, we learned that we were kind of getting a very different story from it. And part of that we found from sitting down with all the students. So we surveyed every student in first phase. And we asked them the question, if a classmate is injured and he doesn't report that injury to the instructors or the medical staff, how do you view him? And the response came back that the majority of students viewed that person as tough or dedicated. And we asked them how they thought the instructors viewed that student. And again, same response, tough or dedicated. So what that does is it paints a story that the actual data that they're collecting on medical injuries from visits to the medical office is not really telling the full story. And even if we were to go down that road of building a predictive database, it wouldn't be built off good data anyway, and it likely wouldn't get us anywhere. But there's another side as well. We sat down and we talked to all the instructors, and we painted this picture of this amazing, magical dashboard where it could tell them for any day in any evolution if there was a heightened chance of an injury happening. And then if it exceeded some threshold, it would suggest they modify the plan for the day. And we asked them, would you modify the plan for the day based on this dashboard? And the answer was pretty resoundingly no. They're pretty happy with their current training regimen. So learning from all these interviews and this data, we set about to discover our true customer or our true beneficiary. And we talked to leadership, instructors, students, medical staff there, anyone we could get our hands on, and it became very clear that the BUDS instructors, the first phase instructors, are our primary beneficiary. Secondarily, we needed to be focusing on leadership as well. And so then we started diving deep on the instructors and what are their main pain points. And as we talked to every instructor, the same 5 things kept bubbling up to the surface as being problems for them, with one standing out, which was the data entry burden of free text comments that they enter every day on these students. And you can see from some of these quotes up here that it's not just the time wasted that they're writing it into their notebook and then going back to the office and typing that in to their kind of clunky database that they use. It's the idea that if they had a better way to do this, they would record more data. And then that data could be analyzed better, and they could actually make some significant improvements to the training program and to the quality of candidates that come out the other end.
We conducted a total of 6 iterations to our MVP, and with each iteration, we would add new features. These features were determined based on the feedback that we got from instructor interviews. Our current version, which is this one that you see, allows instructors to do a variety of important things. For instance, instructors are allowed to choose more than one student at the same time to add a comment to. They're also allowed to choose from a list of suggested comments, and these comments were determined based on data analysis that we conducted in some of the center's databases. And they're also allowed to report injuries, among other things, all from the same app. And again, all of these features were chosen to reduce the time that instructors take to input comments for their students. Currently, our internal readiness level is that of a low-fidelity MVP. And we believed first, actually, we achieved product mission fit when during one of the instructor interviews that we were having, we noticed that the instructor we were interviewing was pulling over other instructors from the same room to show them what we were building. So at this point, we were convinced that they were pretty excited for what we had, for what we were building. And we decided to start coding at that point. However, we reached a low point when one of our supporters, or one of the individuals that we thought was a supporter was actually a saboteur. And when we realized that the app that we were going to build and eventually deploy had to run on Windows 10. So those 2 features made the technical implementation much harder. And instead, what we decided to do was to build a mobile web app that would serve as a proof of concept for instructors to use. So currently, or shortly, there's going to be a new contractor that's going to come into the center. And this contractor is going to be in charge of managing one of the existing databases in the center. And part of this contract includes building a fully functional web app for instructors to use. What we plan to do with what we have is to open source it for this new contractor to use as a guideline, as a framework when they're fully developing their instructor app. And this can be reflected in our mission model canvas under the mission achievement part.
So that's mission achievement for our team, but how do we do in terms of mission achievement for our beneficiary? So as you can see here, we aim to reduce the time spent on data entry by instructors. And we did just that. So our proof of concept app, when deployed by the next contractor, will cut the time spent entering each comment from 9 minutes in total to 30 seconds. And there are a number of reasons for this. One is the intuitive sort of UI of the app we built. Additionally, a lot of comments we found were the same comment across multiple students. So just the ability to select multiple students made a huge difference there. It's about only 60% of comments are actually unique per person. And also easy uploading as a feature that we included. So this will save roughly 21 hours for every class, and this is based on the current comment frequency. So another effect we expect with this app is that instructors will enter more comments and get better data on student performance and be able to analyze that further. Furthermore, we expect that this app will, as we mentioned, generating clean data for analysis, and also improve the training environment because instructors can spend less time on data entry and more time actually observing and training students, which is what they're best at. We also looked at additional applications for this technology. One organization we talked to was the San Francisco Police Academy. They currently just use a system of notebooks and clipboards for their student performance data, so that could be a use case for this. We also explored other options, other military training centers, sports teams at the high school level, at the professional level, and sort of everywhere in between. And then just some key learnings from the course. The first couple here come from our customer discovery process. We definitely could not have learned everything we did without actually going to the center and really experiencing this ourselves. Additionally, sponsor support was really key for us, as we mentioned a couple times. We were not able to arrange 125 interviews ourselves, so that was really key for our problem understanding. Security and legal were roadblocks towards the end, so that was a takeaway for our team. And then also just defense being a really big opportunity for impact for technical students is something that we hadn't thought about before, and this class has really opened our eyes to. And then special thanks to everyone listed here and lots of others who helped us throughout this journey, and thanks so much for listening.
Good going.
You have to hold them.
So our next team is VA Companion. And if I can ask one brief thing of the crowd, if you guys can turn your phones into airplane mode, actually, largely due to this entire operation is being run over Wi-Fi, so we don't want to clog the network. Alrighty.
Hello, everyone. Good evening. We are Team VA Companion, and my name is Bhuvana Dayanandan, and I'm here to represent my team. And that video captured the essence of what we had worked on the last 10 weeks, which is a wonderful experience. But before I get started, I would like to thank the entire VA team that is assembled here, Dr. Harris, Mr. Tony Fitzgerald, Ms. Diksha Ahuja, Ms. Esmeralda Madrigal, Dr. Krissa Agbayani, Sheila Davis, and Dr. Jonathan Sills, who couldn't be here today. Thank you so much for coming and supporting us. So we were given a problem statement to develop a smart home system to enable independence for TBI veterans. That was the problem statement that we got in week 0. And the lean startup methodology taught us many things, but the first thing we learned the hard way was how we needed to actually test the hypothesis and the problem statement itself. And where we ended up was understanding that we need to help the clinicians to be able to get real-time data about the TBI veterans so that they can right-size the care for the TBI veterans, and that the TBI veterans can continue to live their life in their communities, with the independence that they deserve. So that was the aha moment for us in week 10. But we're now going to walk you through how we did. And before I jump right into the journey itself, I want to talk about our team. The 4 of us met just before we met Steve Blank and the teaching team for the interview. We had not known each other, and we couldn't have asked for a more diverse team. 3 engineers and me from the GSB, an MSX fellow, and we couldn't be more different, and that turned out to be our biggest positive aspect of the team to help us achieve what we did in 10 weeks. So just at the highest level, I'd like to talk about the journey itself in 3 segments. The week 0 to 3, as I mentioned to you before, was even for us to be able to understand what TBI meant. Traumatic brain injury, what is that? I didn't even know. So traumatic brain injury is the injury that anybody is inflicted with when their head is actually jolted or in some kind of a traumatic accident or so on. And especially with veterans, you can imagine how extensive that might be. And the first 3 weeks, we just really were like lost about understanding all the healthcare terms and everything else. And we talked to about 35 interviewees, many of them active duty as well as in the VA system. And the second phase, which is week, I would say 4 to 6, we actually talked. We specifically had started understanding the archetypes that help the TBI veterans, the care support system that the TBI veteran has. And then by week 10, we really started to understand, I would say, the tip of the iceberg itself, which is what does the clinician need so that they can actually actively track the cognitive decline or the activities of the TBI veterans so they can intervene in the appropriate time and right-size their care. So as you can imagine, this journey, because we didn't know each other, so we stormed, we normed, we performed, and then we finally performed in week 10. So our journey was quite tumultuous at first, and then we actually prevailed and survived. And I can see myself and the rest of the team actually working together for a long time after this. So with that, I'd like to introduce Kian, who's going to walk you through the MVP and some details around exactly the journey and the MVPs.
Thank you. Thank you, Bhuvana. Yeah, so as Bhuvana said, we have a great team, but we had no experts in the domain. And because of that, the 3 first weeks were kind of tough, and we've learned a lot during this 35 first interview. We've first learned the vocabulary of the VA and what TBI means, as Bhuvana said, but more than that, we learned how does the VA provide care to a veteran with traumatic brain injury. And actually, the only thing you need to remember at that point is that to treat traumatic brain injury, which means memory loss or problems with focusing, we need the clinician to give a specific schedule to follow for the veteran. And the veteran has to follow rigorously this schedule. No, sorry, it's the other way. So we came up with our first MVP. Let's give a schedule to the veteran so that he can follow it. What we did is that we implemented this mock-up app where the veteran would sit down with the clinician. The clinician will tell him the schedule to do on the app, and the app will remind with notification the veteran, okay, John, it's time to take your breakfast now. Okay, John, it's 12, it's time to get a lunch or to go to physical therapy, or it's time to sleep. And we've shown that to clinicians, and they said, oh, that's great. The veteran can now look at his schedule and don't forget to do his schedule, which is the problem. The problem is that the clinician cannot get any data back with that. The veteran can do whatever he wants. The clinician would never see if there is a decline or an improvement on the cognitive ability. So we went back to our interviews, and we said clinician now wants feedback. So how do we do with that? If clinician wants feedback, we need to look what they want and when they want it. So we came up with this second MVP where we take the first app that I've shown you and we add a certain data feedback. There's 3 stakeholders in the VA. There is the clinician, there is the veteran, and there is the caregiver that spends a lot of time with the veteran. What happens is that the caregiver and the veteran can assess when the veteran does a certain action. John did go to the bathroom. John did took his coffee at that point. And the clinician can get back this data and say, okay, John hasn't done his physical therapy for 3 days in a row. It's time to schedule a meeting with John. That's how the data came back. So we've shown that again to the clinician. And what happened is that we learned something very important. TBI is a wide spectrum. You can have mild TBI, you can have severe TBI. Some TBI veterans have partial or full disability. And you understand the consequence. It's that they cannot click on a button to assess that they did a certain action. You would say that the caregiver can click all the time on the button, but the caregiver isn't 24/7 with the veteran. There was a problem here. We needed to track data passively without the veteran having to click on a button. And we're in the Silicon Valley, we have IoT everywhere, we have wearables, Fitbit maybe. We can track this data passively. And that's what we did. We benchmarked the market, what can we track, and we decided to build a product that will not be used by the veteran and the caregiver, but instead it will be used by the clinician to help the veteran live a more independent and better life. So let's look at what we came up for as a third MVP. You can think of a clinician coming into his office or her office and looking at this dashboard where it's displayed, there is a display of many data points on John. And these data can help the clinician make a right decision. There's a bunch of IoT solution to bring this data, but the problem is when we've tested that on ourselves, we've shown it to clinicians, we said, can you tell me if I have TBI based on this Fitbit that I had? And they said, no, what's important to me is some specific data points and some specific thresholds. For example, I would need to know the number of steps that you did in the past few weeks. I would need to know the hours of sleep you had. I would need to have many scores on your cognitive abilities. We have ways, thanks to many companies in the Valley, to track these data passively. But it's not enough. What the clinician really needs is to see when one of these data points went above a certain threshold or below a certain threshold. And these thresholds are set by the clinician for every veteran. It's what we can call patient-centered design or personalized care. Every veteran has a specific threshold set. And so the clinician, Dr. Agbani, who's here, for example, she can sit in front of this dashboard, she can log in, and she can search for any veteran, John, and look at this data coming from John. On the other hand, she will receive some alerts saying, okay, John has slept below 4 hours per day, 3 days in a row. She can also see that the PCL5 score of Laura, for example, is above the threshold she had set for her. Some scores are more important than others. There is a score for the suicide possibility, and we want to know that on time. We want to know that on time. And Dr. Agbani is not 24/7 in her office to see this computer. That's why there is a need for having it on the phone as well, receiving a notification of the right data point at the right moment. And then the clinician can decide to contact the wearable or to take any action necessary. It's actually implemented using the Python Django framework. And here's the demo. I don't know if does it work? So here you see the dashboard. You see the login screen with some alerts. And Dr. Agbani can click here and look at John's profile, for example, because John may have slept less than 3 hours last night, and access this dashboard with some alerts on the lower side. Okay. Can I? Sorry. And with this, having shown you the progress of our MVPs, I give back the mic to Bhuvana.
So in keeping up with the lean startup methodology, we took a look at the get, keep, grow. So what we understood from this project was we need to get feedback by implementing a proof of concept in the next few weeks so that we can get more iterative information and feedback about how the clinicians' workflows are going to be impacted by this prototype and solution. And we are going to keep adding features above and beyond what we already have, which is two-way communications as well as some predictive analytics, perhaps. And then growing beyond the VA, we believe that there's a lot of potential for this prototype to be implemented across the VAs in the US beyond Palo Alto, as well as potentially this application can be applied to dementia and geriatrics and other types of disabilities as well. So so now I want to talk about the lessons we learned. The number one lesson we learned is the importance of the cutting edge possibility of right-sizing care in the healthcare systems. That doesn't exist. So this would actually be at the cutting edge of starting a process where the VA can become the pioneer of doing something that's so important and showcasing how it's thinking about a problem that's broader than just a segment of the population that it serves. And obviously, the thing that we learned is the simplicity of the solution is really important because it impacts a big team of clinicians whose workflows are going to be impacted. So the usability and the user interface is quite important. And obviously, we will actually need to consider the beneficiaries and the support system of the TBI veterans so that our vision, or the VA's vision for making the TBI veterans have an independent life and be able to live in their communities is actually a reality. So in order for that to happen over the next few months/weeks, Monica here has got a HAAS Center funding to continue to work on it in the summer, and a couple of us potentially will continue to work on this in the fall by seeking some additional funding and keep moving forward in making this a reality and a possibility. Thank you.
So our next team is Team Lumina.
We are Team Lumina, and our sponsor is the Technology, Innovation and Solutions Division of the US Southcom. Together with JADF South, the Joint Interagency Task Force South, Southcom coordinates detection, monitoring, interdiction, and apprehension of all illicit maritime activities in Central and South America. Combating narcotics trafficking is a joint effort between the US and partner nations. Today, the coastal route from Colombia to Mexico accounts for more than 90% of the cocaine destined for the US. This movement of illicit narcotics threatens the safety and security of nations. JADF South coordinates interdiction missions with foreign command centers. However, at the tactical level, the reliance on cellular networks and radio communications results in limited area of operation and high communication latency. Interceptor crews know very little about where both blue and red forces are. The lack of situational awareness can severely impact mission success. We propose a two-part solution. The first is a commercial off-the-shelf, ruggedized satellite device designed to help travelers stay connected anywhere in the world. Leveraging this connectivity, the second part of our solution is a situational awareness application. This mock-up shows the map interface where users can plot the location of illegal vessels that they spot during a mission, and this information will be instantly shared with other users. The application also enables two-way text communication. With this, users will not only be able to identify location of targets, but also friendly or neutral vessels in their vicinity. Together, The two-part solution provides situational awareness through fast, reliable, and affordable mission communication. This intuitive interface will also bypass the language barrier often faced by US forces when they work with our foreign partners. US and partner nation forces have told us that this solution is highly desirable. We are now pursuing the next step to bring our solution into the hands of JALF South and our foreign partners.
Yeah, I hope you guys enjoyed the video. Before we begin, I think we'd like to give a quick shout out to our sponsors at Southcom, Lieutenant Colonel Todd Moe, Dr. Andrew Heiger, and Mr. Juan Hurtado. Which I'm sure you're watching this video live from your home in Miami. Although you guys haven't seen us before, but yeah, I hope today you'll be proud of us. And also, last but not least, to our mentor, Daniel, who talk to us every week and spend a lot of time whipping us in shape for this presentation. So thanks, Daniel. Yep. So what the video covered was kind of like an overview of where we are currently at with regards to our problem and solution. So currently, we are solving the problem of a lack of situational awareness, specifically for foreign partners. But this is drastically different from where we started off 10 weeks ago and before the 101 interviews that we conducted. And at week 0, we looked at the problem of illicit maritime activity detection and monitoring really broadly, and with a solution focused on data analytics. And behind all of this is the 5 of us, Team Ostrum Lumina, myself, Xuan, Sam, Benjamin, Vishak, and James. So with our diverse backgrounds, it really helped us to handle the challenges that we faced along the way. And but we would not have been able to do this without the support of all the people who we have spoken to from both the military and the industry. And they really helped to enlighten us along the way as we went through several problem scopes, discovering before we achieve product mission fit. So correspondingly, we developed even more number of MVPs in response to these problems and related the problems to different primary beneficiaries, which we will all cover in the presentation that's following. Now, with regards to our emotional journey, we had our ups, but certainly our fair share of downs. And now the team will bring us through all the aha moments that we have experienced, starting from week 0.
Thanks. Oops, wrong direction. So we took these several journeys together, and as they say, a journey of 1,000 miles begins with a single step, or in this case, a single interview, and also the single lesson that we didn't really know just how much we didn't know when we set out on this journey. Though some of us had a military background and others had worked on problems that we thought were related, we realized that there were a lot of things that were different. The way we first started to think about this was to understand how our sponsors saw the world, and as the video discussed, they think in terms of targeting, detection, monitoring, all the way through to the ultimate apprehension of some element of an illicit network, or otherwise disrupting of an illicit activity. That's where we first focused at the beginning, because we felt that if we had a solution that was upstream of the problem, it'd have the most downstream impact. We wanted to target targeting and detection for analysts with tools that would use existing data, like satellite imagery, to augment their existing workflows. But our first key finding, and this sounds not as profound as it actually was the ocean is very, very big. Bear with me. What we came to understand was that indeed across millions of square miles of ocean, you might have at any given time one friendly asset. And this sheer scale involved of just how large the problem was and how complex it was really informed our learnings. And the fact that something might take days to action, even if you could detect it, led us to begin to wonder whether that was really the right approach. The second finding related to this was that there just wasn't necessarily the data on hand that we thought there was to help us with the unique and crazy Stanford analytics we wanted to try. And what we did then, as we spoke with our sponsor, was look at another part of the problem in terms of monitoring to help develop that data that could later be used. That led us to our first pivot from detection to monitoring, where we wanted to focus on an autonomous, low-cost platform that will allow us to have that kind of sensor capability that was missing at the moment. So this had a shifting a little bit into monitoring on that framework. But as we started down this path, we realized that there were a couple of other issues. For example, that both the Air Force and the Coast Guard felt like that wasn't necessarily the problem either. And indeed, as we spoke with people, we realized that asset constraints were really a serious limitation. This was borne out as well by data showing that of the known threats that were identified or even targeted, very few were able to be disrupted, in most cases just because there were so many potential threats and so few assets available. Not because of any competency issues. Everyone was very good at actually disrupting them. With that being not the bottleneck, our question then was, can we make missions more efficient and therefore serve the overall mission of Southcom? And that led us to the second pivot to look at mission efficiency. And in turn, shift into interdiction as well. Sorry.
Okay, so in order to improve the efficiency of the mission, we spoke to various stakeholders and found that there's great value in predicting and narrowing the search area. So by doing so, the Joint Interagency Task Force, JIDA South, can then predict the red forces' behavior and allocate the blue forces more effectively. More importantly, JIDA South can then capitalize on the assets of our foreign partners and make up for inherent asset constraint. However, we hit yet another wall when we realized that JIDA South sometimes do not even have the entire situational awareness of all friendly assets in the region. This reveals a fundamental challenge with the tactical communication with our allies. This leads to our third and final pivot, where we aim to address this lapse in communication that is hampering the coordination efforts of JIDA South. So underpinning this lapse are three inherent tactical issues. Firstly, is the limited communication range of existing systems used by our foreign partners, the low reliability and quality of radio communication that is used out at sea, as well as the language barrier between the US forces as well as our foreign partners. Hence, tackling these three problems, our MVP is a two-part solution. So, firstly, the first component is a satellite device that aims to bridge the gap and address the limited communication range of the existing systems, while our second component is a visualization interface that provides situation awareness as well as a direct two-way communication channel, as mentioned in our video previously, that aims to tackle the latter two problems. Upon reaching this stage, we finally achieved product mission fit, where we not only managed to hone down to the most pressing problem, but also devise a solution that is not only validated, but also desired by the people on the ground. So, summarizing our journey on discovery over the past 6 weeks, we have seen that our problem has evolved drastically over the past 6 weeks. From one that is addressing data analytics in week 1, through about 7 iterations and 3 pivots, arrive at one that is tackling the tactical communication in week 6. Our primary beneficiaries have also evolved to include our foreign partners, and these findings are summarized in our mission model canvas as shown. However, we have also learned that finding the right solution definitely did not mean that's the end of the problem.
This is an extremely complex space with very complex workflows and complex influence hierarchies. And this complexity directly impacts the way we think about deployment. In particular, 3 key factors influenced the way we thought about our MVP and deployment process: trust, which speaks to buy-in and support; information security, which speaks to the deployment process; and upkeep costs. When we initially thought about buy-in and support, we quickly saw that trust was something which was really, really important, and it was something that was sometimes lacking. Accounting for this key element of trust was really important if our foreign partners were to adopt our solution. For example, the flow of information in tactical communication is quite unhampered. However, in the operational level, trust puts restrictions in place which hampers flow of information between the US and partner nations. So addressing this key element of trust by giving more power to the foreign partners in sharing information as and how they like is key to having them adopt our solution and having more adoption. When we started building our MVP, we did not really think about information security issues. But as we spoke to our beneficiaries and stakeholders, we realized that it is of key concern for them. What we understood was that they didn't want to really reveal information about the pattern of life to the enemies, especially because of the fact that they're growing so sophisticated day by day. And we also learned that many startups fail to take this into account when they build their products. And we want to mitigate this by engaging security experts early on in the development process. What we also realized was that oftentimes the people who buy our solution are different from people who end up using it. So cost is of key concern in this space. And what we learned from one key stakeholder was that communicating common situational awareness took up a huge bandwidth, and it was really, really expensive. So addressing these issues is really important. And the way we do it is by leveraging existing technologies like handheld devices and by minimizing communication costs for this.
So reflecting on all that we learned and these three journeys of product, beneficiary, and our own emotions, there's a lot that we had to take away. Where do we end? Ultimately, the path forward is going to include pursuing additional funding through either the Office of Naval Research or US Southcom to explore this topic further. But at the very least, whatever we do, we're going to make sure that this work can be bundled up, passed off, and used to advance these sort of questions. But there's a lot of other learnings that we have beyond this that you can find on our blog. It speaks to just how much of this course that we'll take away and apply later onwards. In terms of where we end, we have a relatively good prototype, as you saw in the video, I hope you found, and more details, again, are on the blog. And lastly, we just want to once again stop, acknowledge, and thank everyone who made this possible, from the interviewees to our sponsor to our mentor. If you have any questions, please reach out. And again, you can find more about us on the blog.
We'll have a presentation from Team Explomo.
Camouflage and simple-to-make improvised explosive device, or IED, caused its first American fatality in Afghanistan. Over the next decade and a half, these devices would be responsible for up to 2/3 of all combat fatalities. The problem with these IEDs was that they were near impossible to find with the untrained eye. GINO, a DoD organization set up to develop counter-IED measures, thus approached us with a proposition. Create a portable drone capable of detecting IEDs. Gaining understanding of the IED placement and avoidance workflow, we identified ground infantry units as the primary beneficiaries of our drone product. Upon specifying this, however, we soon ran into a major problem. The need for a drone did not exist. Infantry units already used the standard RQ-11 Raven. Adding new hardware would likely mean resistance. Puzzled as to how to move forward, our frame of thinking was completely shattered by an Air Force intelligence officer. We don't use tech to analyze the Predator feed. We have 30 guys in a room for that, so the Predator's capabilities are only as good as theirs. Shocked, we thought, if an advanced drone like Predator relied on dozens of specialists for video feed analysis, how could an infantry unit with a less advanced drone and with one drone operator who doubled as analyst match the capabilities of the Predator team? We thus realized our beneficiaries' true needs. Ground infantry were lacking a means of understanding the data they already had. What these soldiers really needed was an analyst in their hand, a software that scanned the drone's feed and detected potential signs of IED emplacement. Understanding the enormous complexity of the problem, we limited our program to detecting anomalous potholes in the stern earth, ultimately creating a joint anomaly detection and machine learning algorithm. We successfully are able to detect these signs, thus providing warning to the drone operator. Following the software approach, we've created a much more robust solution, capable of being scaled quickly for widespread deployment, Looking forward, we are working to further refine our software product because we are confident in its abilities to help in situational awareness, because we are proud to serve the needs of our troops, because we are hopeful the day will come when the IED threat is no more, because we are Explomo.
Whilst we're waiting for the presentation to load, we'd just like to give a big shout out to our sponsor, Jaido, who's watching via video link. Thank you very much for the support that you have rendered to our team over the past 10 weeks. So very good evening to all of you. We are Team Explomo, and the problem that we are dealing with is really standoff detection of IEDs using unmanned aerial vehicles. And there's been a lot of change since we started on this project 10 weeks ago. When we first started off, our original focus was to try and build a hardware drone, a small man-portable drone that basically uses different sensors and could potentially replace human capabilities in detecting IEDs. Over the course of the 10 weeks, we have evolved our approach, and our current focus is really more focused on a software solution, an image processing system that could potentially augment the human in detecting the IEDs and can potentially be scaled much quicker. To get to these insights or to help us transit over the last 10 weeks, we have had the benefit of speaking to more than 103 stakeholders from a variety of groups such as government, Jaido, and of course industry and also academia to try and understand it. And to do this work, we've had the benefit of working in a very interdisciplinary team. Our team comes from the School of Engineering, Business, and also Medicine. So now I'll move on very quickly to our journey. So not unlike the other teams that have presented before, it's been a roller coaster ride, I think, as you can see from the chart on the screen. But we'd like to emphasize that there are essentially two phases to our journey for Team Explomo. The first phase, which is the part shown in red on screen, basically is from week 1 to week 5. That was the phase where we focused very much on a hardware solution. And in this particular phase, you could see that we actually plateaued at quite a low level. And subsequently, in week 5, we made a pivot towards a software solution. And then our confidence started to pick up because we started to make greater progress in what we were trying to do. And you can see that it ended up in a higher plateau on the green side of the chart on the left. So we understand that the IED problem is not a new one. In fact, it's been ongoing for a long time. Jaido has spent significant time, resources trying to crack this problem. So not wanting to reinvent the wheel, we actually went about understanding the evolution of IED and counter-IED technologies. And we essentially settled on our initial hypothesis. Why don't we give a state-of-the-art drone to our warfighters and then make it multifunctional such that it would be able to detect all sorts of IEDs. So excited with this, we went about seeking the beneficiaries who would potentially use such a solution, and we found many, including vehicle convoys, dismounted infantry, analysts, special operations, and even route clearance teams or EOD teams. And we were thinking to ourselves, wow, this is great. If we're able to invent such a drone, many people will be able to benefit from our work. But ironically, this really brought us to quite a low point. And one of the reasons why this happened was because we realized that we were trying to boil the ocean. Our problem set was really too wide, and we were trying to do too much things. As we spoke to each of the beneficiary groups, each of them gave us feedback that whilst they were dealing with the IED problem, it was really not the same context. There was some nuancing in the types of technology and the types of operations that they were running. And with this new insight, we then went back to the drawing board and we really decided to dive deeper into understanding what the IED cell would do, what is an adversary, and how would they think, and how the US military would respond to find an opportunity space, and we managed to identify an opportunity space. And our first aha moment came when we spoke to an infantry commander who actually told us that infantrymen are the most vulnerable to IED attacks. And whilst they were trained to detect IEDs, really they were largely using their eyes. And we were thinking, even this is quite a big group of beneficiaries that we could work towards, and it would be a very useful thing to focus on. So we decided to really focus our approach on the dismounted infantry, who would require standoff detection capabilities and who would also require near real-time detection capabilities. And this helped us focus on developing a value proposition that was really focused on trying to serve the needs of dismounted infantry, and we started to make a little bit more progress there.
All right. So, given the fact that we had identified the beneficiary, and worked on identifying the problem and specifying it more, we were all gung-ho to start building the drone and start developing that option. Unfortunately, when we talked to our customers and proposed them this great idea, we thought, they were not very enthusiastic. They said, we already have surveillance drones. For instance, infantry units already use the standard RQ-11 Raven. So what would be the point of us bringing them another drone? We thus, we thus were significantly impacted by these statements by these infantry commanders, and as such thought, if we're not going to build a drone then, if they don't need this, why don't we then change the drones that they have and make sensor additions to them, help to improve the capabilities? So we looked to potentially add sensors such as hyperspectral cameras, different chemical sensors and such. And going through this, we thought that this would help in situational awareness. Unfortunately, again, talking to lots of customers, we found that our hypotheses were wrong. And we really needed to get in contact with these people in order to change our opinions. So first off, one of the reasons we said that sensors wouldn't help in situational awareness is because on their own, they don't give analytical insights. So we were focused just on appending a sensor and voila, the problem will be solved. Unfortunately, if you don't have really a background software behind it, analyzing, a sensor is not really going to do anything. Additionally, sensors aren't perfect. So we talked to a lot of different sensor experts in explosive signatures. So for instance, looking at the chemical sensor, in an area such as Afghanistan, in an arid environment, a chemical sensor would not be so great because it couldn't pick up too many vapors. And finally, the biggest reason why we really decided to pivot away from the sensor approach was the fact that it would be very almost impossible to deploy this, given all the regulations and financial constraints imposed via DoD. It would be very hard to add these sensors. And so, again, we were at rock bottom because of this failure in being able to create a hardware solution. So what did we do? Again, we had to go to customer discovery. And we started speaking to intelligence analysts. And speaking to Air Force intelligence analysts in particular, we found that when they were looking at the feed, they would primarily just use their eyes. They wouldn't have too many tools outside of just their own visual capabilities. And the fact that they would miss things from time to time seemed to us, this seems like an opportunity. And so talking to those specialists, getting out in the field, talking to individuals who actually dealt with the complexity of the IED problem, we looked to improve our understanding of the issue. And here we were able to really limit the problem in terms of looking specifically for one object. So prior to this customer discovery, we had been looking for all sorts of IEDs, all sorts of signs, wires, etc., everything. Now, we found that potholes were a really good thing to look for because they were one of the main visual indicators. And so we could update our mission model canvas based on all of this customer discovery. First off, we would no longer be replacing the warfighter's capability to detect IEDs. Instead, we would be augmenting it, simply because, frankly, right now, we're not going to be able to replace the visual capabilities of a soldier. And so we wanted to create a software solution. Also, given that we wouldn't be focused on creating a drone, we'd be drone agnostic and also focused on pothole detection. As such, the biggest pivot in our project was thus switching from the software to the hardware solution. Essentially, one can say an analyst in the hand. So it would be some type of software, an algorithm developed, which we'll talk about in a little bit, that would essentially help the infantry drone operator analyze the feed they had. So we found that our confidence really rose at this point, and we had met the MVP and beneficiary needs matching. So because we identified this MVP and presented it to our customers, they agreed with it, and we said, okay, let's start developing this. Let's try to develop a software solution. So we had two things now. We could look to identify deployment strategies and also software solution development. So one of the things we did was, of course, identifying deployment. And the really big part of this was just that JIDO would be the most important part of our deployment process, given that JIDO is the one going to be acquiring our product. JIDO is going to be the one pushing our product out to the infantryman, out to the drone operator and such. So JIDO would really be the integral component between connecting us and the end user. And thus we could look to improve our mission model canvas, identify our specific partners. One of the big things also in the fact that we could identify the software approach was that we could finally identify some mission achievement metrics. So we would want, for instance, if we were going to implement a software, less than 5 errors per frame, a very high accuracy rate, and we could thus identify this mission achievement.
So in order to develop this method algorithm in a timely manner, we had to iterate faster our solutions. So we started off with a well-known feature detection algorithm called SIFT and applied it to pothole detection. And this algorithm works well, sometimes. So it's not very robust. So we did a thorough literature review and also wrote image processing method review paper. And from all of these sources, we basically concluded 2 potential avenues for further development. So one is the basic anomaly detection based on contrast. And another one is machine learning methods that can be trained very well to detect specific objects, in our case, potholes. And these 2 approaches are complementing each other. So we coded them up and did some initial testing to successfully demonstrate pothole detection. So while developing these software solutions, one of the key activities we have to pay attention to is make sure that the softwares match JIDO formatting standards. So our final MVP would be a software package that is a combination of machine learning and anomaly detection. And it could be deployed on an existing aerial platform to provide the end user the analyst in the hand capabilities. So our software is currently in initial stages of development, and it definitely needs further development in the future. So we would rate our team readiness level as 4. As we move forward, we foresee in the near future significant improvements developing this software for military use, but we also expect encountering several dual-use opportunities. And with this, I would like to conclude the presentation and thank all the listed parties.
Thanks for the first 4 teams. We'll let everybody exhale for about 10 minutes, and we'll be back in 10 for the next 4 teams at 6 o'clock. And then there's a reception at the end. If you survive all 8 teams, we'll have some drinks.
Recording this? Who will be looking at it?
That I can't answer. Whoever
We're going to see it live. help.
It's like
You get the, class we're doing East 104.
My kids. Sorry, I actually lost my kids. Yeah, well, that's because they're in this life.
All buyers. Thank you for participating.
Oh, you bet. They did a great job.
Hi, Donna. How you doing? Way to go. Yeah, I'm Tom.
Yeah, I've met you once.
Yeah, you look familiar. In our department?
Yeah, I never said
Yeah, that's what I thought. Yeah.
Yeah,
All right, Tom, well done. Well done. They'll be lucky to have you. We were lucky to have you. So, and all the DCIers. DCI. Yeah, right? I'm one of the if you're going to be here for anytime, forever. I can't. I plan on doing it. 5 years when I ended up here.
Nobody can translate. They give us, it does this. You're saying, you already have that. And these guys have that.
Oh, yeah, you know,
Oh my gosh. Oh, they really were. Yeah. She would like it.
what sort of courses are you taking?
Today's VA actually see the standard and it's better than Are you guys going to stay for the second half too? Or snacks after?
Congratulations. You guys did a good job.
Yeah, I mean,
Oh, yeah.
Well, thank you for helping me, and I hope you'll do it again. Well done. So proud of you.
We are right around 100
Well, I was prepared. So, all right, so brand new. It's really good to see you. It's a brand new facility right on the bay. Right on the freeway.
It's a joint venture, so it's our first tech upgrade. So we actually have digital soldier, we have pediatric,
Yeah, I was really pleased.
Did you do your fan speech from the DJ booth? What were you like?
Almost pointed to it.
And he's our first director of the so there's 3 parts of the VA.
I hope you'll see this video. Send it to them. Invite them anytime to come by and get the full, we were used to those kind of first forms.
They actually had to sign some thank you cards. Are you guys thankful for the sponsors application team? Have a box. So apparently last year there was not even a spot left.
They were
Yeah, and you guys did. They were all right,
Do something that's closer to the user rather than that's the pivot that everybody has got. The second thing that get a better
only talking right? So we asked you first. And then
And at first they that has been, talk to the user, find out what they're looking for.
So let's get seated. We're going to see the next 4 teams. And then we'll all get to celebrate out in the courtyard. Teams and their sponsors. Microphone. We're going to do the next 4 teams. And then we'll celebrate out in the courtyard. And those watching online could celebrate virtually. As you could tell, we're incredibly proud of all the hard work the teams have done, the effort their sponsors and mentors and teaching assistants and the rest of the teaching team have put into this class. And someone just asked me, the intent, at least from the teaching team, was to connect students who, I think if you ask them, probably never would have thought about working on problems with the Department of Defense or intelligence community because of all the other opportunities here at Stanford and other research universities. But for us, I thought it was incredibly important to allow our students to work on some of the toughest, but mostly some of the most important problems the country has. And I think you saw already how many of those teams are by themselves going to continue on working on those problems. And that's just a wonderful outcome of this program. So without hesitation, who's the next team up?
Team Security.
Security.
This is Team Security. Our team has been working with U.S. Transcom on improving cybersecurity assessment for United States strategic ports. Strategic ports are commercially owned and operated ports that U.S. Transcom utilizes to transport military cargo. Given that over 50% of this cargo is transported by sea, maritime facilities are a critical asset in the global supply chain. However, with increased use of digital systems to plan, control, and coordinate port operations, U.S. Transcom needs to understand the cyber resiliency status of their strategic port partners in order to ensure undisrupted flow of cargo in cases of military crisis. Therefore, our sponsor tasked us with developing a set of standards to effectively assess the cyber resiliency of the United States strategic ports. Our initial research with Transcom, Surface Deployment and Distribution Command, U.S. Coast Guard, and port representatives led us to believe that extensive cyber research had already been conducted by subject matter experts, and that U.S. Transcom simply required a way to aggregate and visualize this port-specific data. However, we soon came to realize that conflicting goals and interests between beneficiary parties meant our initial ideas of data aggregation and visualization did not meet the standards of a product market fit. The problem was that our core assumption was incorrect. We realized that while work in the cybersecurity domain was growing, there was no port-specific framework to fit the unique infrastructure needs and capabilities at port facilities. Therefore, we went back to square one. We got out of the building to identify the bare minimum, key critical infrastructure needed for U.S. Transcom to continue moving cargo through a strategic port facility. We took inspiration from existing academic and industry standards and began mapping them to the port environment. Our current framework clearly defines and prioritizes cyber risk within a given port facility based on the criticality of each specific infrastructure capability and its associated attack surfaces and vulnerabilities. We identified key partners in SDDC and the Maritime and Port Security ISAL in order to determine how our framework could be utilized on the ground. Moving forward, we hope our framework will serve as a baseline for U.S. Transcom to build out a robust cybersecurity assessment for strategic seaports across the nation.
Hi everyone, we're Team Security, working with the United States Transportation Command and Colonel Matthew Lear as our sponsor. Originally, we were tasked by Transcom to evaluate the cybersecurity risks and level at our nation's seaports. After 97 interviews, what we've come to is a more narrow definition of our problem, where we're going to create a port-specific framework to evaluate the cyber risk at our nation's strategic seaports.
So this is our team. I'm Valerie. I'm a junior here studying computer science graphics.
I'm Stanley, a sophomore studying computer science.
And I'm Benji. I'm a master's student studying public policy.
And we worked with Mr. Roy Chapati from Stellar.ai as our mentor, Mr. Peter L. Higgins, and our TA was Darren Howe.
Right, so we conducted interviews with a total of 97 people. A more detailed breakdown of where these people come from is shown here. But generally, this was a mix of Transcom officials, port authorities, cybersecurity experts from the industry or academic fields, and people from other maritime and military organizations.
Great, so this is a snapshot of our week 0 mission model canvas. A couple things we want to highlight. First of all, just how broad we started. You can clearly see we were really trying to boil the ocean at the very beginning with the value proposition we created, you know, like doing everything on the cybersecurity space for the ports when there really was not much being done. And also just our beneficiaries, you know, the United States Armed Forces, like the broadest thing we could label. Yeah. So clearly, you know, we didn't have much experience in this space and we were just jumping right in. There seemed to be a lot going on already, tons of players in the market. And also a lot of research already being done, you know, reports from the DHS, Coast Guard, and also NIST standards to read, tons of research for us to go through. So what we really thought, initially thought was that Transcom just lacked a clear understanding of the ramifications of cyber attacks on the nation's seaports. So we thought, hey, we should give them a visualization tool so that they can understand at each given port what the ramifications of a cybersecurity attack are. What we quickly found is there's already an existing tool for that called Dagger. And also what we learned and realized is that we really needed to start prioritizing commercial partners at these ports as well, because ultimately they'd be the one footing at least part of the cost and also implementing out the solutions that we provide. So as you can see, this is reflected in our week 1 mission model canvas.
Right, so having just identified that these commercial partners at these seaports would probably play a critical role in our project, we decided to shift the angle of approach to our problem and figure out, hey, maybe we need to find a way to provide direct value to these commercial partners and improve their cybersecurity and indirectly improve value for Transcom as a result. And so to do this, we pivoted to a second MVP essentially, which was a bug bounty platform through which these commercial partners would basically offer their cyber systems off to third-party hackers who would in turn exploit these systems for vulnerabilities. The commercial companies would learn from these attacks about how to improve their systems, and Transcom, meanwhile, would collect data from this platform to improve their understanding of what kind of cyber vulnerabilities existed at the port level. We quickly realized, however, that this was already being done as well. So much like our visualization tool idea, a host of other companies like Cadium and Synac were already making a solution like this in the works. And on top of all this, we learned that ports are generally very reluctant to share critical information about their systems. So not only is our idea already being done, it's basically very difficult to implement without having to change a whole wide variety of contracts and providing financial incentive. So at this point, we really kind of bang our heads against the walls because every idea we had thrown onto the table was basically already being done, not ready to be implemented, or like not very novel at all. So we were suffering some low-key internal crises at this point, but we decided the best thing to do was to simply step back and actually learn more about these ports because our understanding of the problem was still very limited. And so we decided to actually go out, take a trip to the Port of Oakland to actually learn more about how ports operate. And so this port trip was very informative. We managed to map out a whole series of critical infrastructure at these ports that were susceptible to cyber attacks and actually learn about how these systems interact in real time and what people on the ground at ports actually do and how these cyber attacks would affect them. So kind of the key activities we accomplished through this period of our journey was really mapping out these critical infrastructures and really understanding the problem.
Yeah, so as Benji mentioned, basically at this point, our MVPs were vacillating all over the place. Everything we had come up with seemed to exist or was not very feasible. And the core problem was really just we didn't understand who our beneficiaries were or what the key pain point we were trying to solve was. And the teaching team picked up on this and they kind of said, hey, do you even know what frameworks are being used? Can you clearly define what the pipeline is for cybersecurity assessment right now? And so we went and looked back at our old interviews and went back out to our beneficiaries. And the one that kept coming up was NIST. I'm sure a lot of you have heard about it. And we looked at NIST and we started reading the paper. And we realized this is a really broad framework. It is meant to be broad. It's meant to cover a wide variety of organizations, big, small companies, federal and private organizations. And that meant that we realized our beginning core assumption was very incorrect. We had assumed that the research that Stanley mentioned by DHS, Coast Guard, was enough of a framework to kind of build up some sort of technological solution. But that really wasn't the case. There was no port-specific framework baseline. All of our beneficiaries really had to map NIST down to their environment, and that's very difficult for them to do independently. So we decided this is really where we can best come in. We're not cybersecurity experts, but this is really the pain point that needs to be solved. So we decided to go back to square one. So we started out by finding a proxy. Stanford IT security people here helped us out by giving us their standards. Combined with NIST, we started identifying critical infrastructure and kind of mapping it into a low, medium, high risk sort of system. When we brought that to our beneficiaries, they mentioned, hey, mission criticality has to be part of your framework because it's not enough for us to just know what the attack surfaces are. We have to know how that impacts our mission and our mission achievement. So we added that as another layer. And basically, a high-level skeleton kind of looks like this, where you have the attack surfaces combined with the mission criticality to aggregate into a score. And out of that, we can also provide some risk alleviation guidelines, much as NIST does already. So we thought, OK, we're good. But the teaching team said, OK, are you just going to give Transcom that piece of paper and be done with it? Like, how is your framework going to be used? So we realized we have to really look at how this will be integrated on the ground. And originally, we thought we would integrate it into SDDC's existing pipeline. So the Surface Deployment and Distribution Command basically is in charge of doing the current physical assessments. So what would happen is like they have an existing scoring matrix questionnaire for their physical capabilities. We would just add our framework as cyber questions and cyber scoring matrix for them to look at the ports. They do this once every couple of years. So max once every 2 years, most likely once every 3 to 5 years. But our beneficiaries were telling us they want real-time data because cyber is really a dynamic space. And so that was really important for us to try to tackle. And in particular, Ms. Hebb actually pointed us out to the Maritime and Port Security ISAO. This is a really new information sharing and analysis organization that's being set up specifically for the maritime and port space. Basically, they're setting up platforms for information sharing within this environment. So we realized that the MPS ISAO currently they're forming partnerships with commercial port authorities, with other federal agencies, with industry partners, and trying to collect this data into a very secure information sharing friendly way. Transcom wants to understand this space, and Transcom is working with us to develop this framework. MPS ISAO has also declared that they are also struggling with the NIST problem. So we thought, hey, this is a really key partnership opportunity. So we managed to actually get Transcom officials on a joint call with the executive director and the director of strategic alliances at MPS ISAO. And we're really hopeful that this is a partnership that can really be beneficial for both parties moving forward. So MPS ISAO, we added to our beneficiary list as a partnership opportunity with Transcom. And our final framework right now, we're still kind of fleshing it out, but we basically have started mapping down specific categories, specific infrastructure we're looking at, and talking to people at like Navis and other terminal operating systems to see how those categories look like on the ground.
Great. So looking at what mission achievement looks like for our primary beneficiaries, first, for Transcom, we really think that it's improving understanding of cyber readiness at the national level, and we really think that our framework slots right in there, helping them understand and ultimately build out a more robust framework to understand and categorize each strategic seaport. With respect to the commercial port officers, as we remember, they're incredibly important as well. We really think that these guidelines that we release will help them improve their own cybersecurity and protect themselves from cyber attacks in the future. And for MPS ISAO, we really think that the partnership with Transcom will be really helpful when they go talk to other organizations, and also it acts as a new data channel that they can acquire information from. In terms of internal readiness, we think we're about stage 5, where we're currently developing the product and also demonstrating it in front of our primary beneficiaries. For next steps, first, we really think that we should continue refining the framework and ultimately submitting a report with that framework to our key beneficiaries. Second, we think that we should continue fostering the partnership between MPS ISAO and Transcom because we really think it's really crucial and beneficial for both parties. And finally, we really hope that these two organizations can take our framework as a baseline to ultimately develop it out to a full standard that they can use in the field. We'd really like to thank the teaching staff, our sponsors at Transcom, our mentors, Roy Chapati and Peter Higgins, who are both in the audience here, and all the interviewees who have taken the valuable time out of their day to talk with us. Yeah. Thank you.
We are Hacking for Defense 2017 Team Surgency. Our sponsor is the U.S. Army Medical Material Agency, or USAMA. We were tasked with improving time-critical combat care under a mass casualty response, given the DoD's shifting focus towards major power war with near-peer adversaries. 90% of combat casualty fatalities occurred pre-medical treatment facility in the past decade, a quarter of which were deemed survivable. We realized early on that we would have the most value somewhere from point of injury to pre-evacuation to a Role 2 or 3 treatment facility. We define mission achievement in terms of lives saved. By getting out of the building and talking to both medical and non-medical staff along the chain of care, we mapped out the key players, functions, and pain points present from point of injury to pre-evacuation at a Role 1 battalion aid station. In a mass casualty scenario where medevacs are limited, casualties are transported from point of injury to the battalion aid station. There, a triage manager oversees the triage of incoming casualties. Inside the battalion aid station, the senior medical provider, typically a physician's assistant, manages the queue of casualties incoming the station, receiving treatment, and outgoing on medevacs. Medevac information is then relayed to the medical officer, who handles the tactical coordination of evacuated casualties. After learning more about the mass casualty response practices at a battalion aid station, we identified that mass casualty response at this stage is a management problem, not a patient care problem. Further, physician assistants would benefit greatly from an increase in situational awareness in both treatment and triage, as well as in evacuation decisions. With these pains in mind, we have designed an MVP to facilitate inter-battalion aid station communication and casualty monitoring. Upon reception at the battalion aid station, vital sensors will be placed on all casualties and secondary triage officers will record missed data through a mobile interface. On another screen interface, physician assistants will have access to continuous vitals measurements from the sensors, as well as the information previously recorded by triage officers. After showing our MVP to projected beneficiaries at the 23rd Marine Regiment, we received good feedback which will be reflected in future development iterations. With this MVP, we hope continuous tracking of casualties decreases the preventable loss of life. On behalf of Team Surgency, thank you.
Oh wait, this is kind of giving away the punchline a little bit there. Hi everyone, I'm Abby. And that's, yeah. And we're Team Surgency. And our sponsor is the United States Army Medical Material Agency, and they tasked us with improving operational medical care. Week 0, we started off at a completely different place than where we are now, and we were tasked with developing the capability to deploy robotic telesurgery in combat environments. However, after 10 weeks, over 90 interviews, and a lot of lessons learned, we're now addressing triage and treatment bottlenecks during mass casualties at a Role 1 battalion aid station. So with this new problem in mind, we have developed an MVP that essentially improves intra-BAS communication and casualty monitoring to improve situational awareness at battalion aid station level. So just to give you guys a brief background on our team, we're 3 undergraduate seniors and 1 co-terminal master's student, all engineers in bioengineering, electrical engineering, CS, and mathematical and computational science. And we'd just like to take a moment to thank our wonderful sponsors and mentors, some of which are here today, for your invaluable expertise and just really being there every step of the way throughout this journey. And we'd also like to thank all the people that we interviewed. We were able to interview deployed medics, surgeons, physicians, tactical commanders, as well as some of their civilian counterparts, and also academic and commercial industry experts. So we had an incredible journey over these past 10 weeks. Starting week 0, where we started at a really big high point, where we were given a very defined problem statement, basically allowing robotic telesurgery to be deployed to allow time-critical life-saving treatments for casualties in austere environments, particularly. However, week 0 customer discovery really kind of led us to believe that there are some intrinsic bottlenecks to surgical robotics that maybe aren't addressable by our team in 10 weeks. So that kind of led us into a tailspin into the trough of despair week 1, where we were kind of facing an existential crisis of where are we going, what are we doing, and particularly where can we add the most value along a really complex and dynamic chain of care. So to kind of break us out of that existential crisis, we visited the 129th Rescue Wing at Moffett Airfield, where we were able to talk directly with people who are on the ground providing care to soldiers. And we really got a good view of the day in life and some of the challenges that they face. And we really learned that, this is the wrong one. We learned 2 things. One is that most casualty fatalities occur before arrival at a medical treatment facility, and more astoundingly, 25% of these fatalities are deemed survivable. So where can we add the most value? We decided it was from point of injury to forward care. And also another key takeaway from getting out of the building was that mass casualty scenarios were identified as a critical bottleneck that almost entirely overwhelmed the resources at hand. And even more importantly, that casualty care at this point is not a patient care problem, but a management problem. There you go.
Okay. So with the insight of mass casualty pre-evacuation triage as a management problem and not a patient care problem, we had the unique opportunity to have a second day out of the building. And this was at the Stanford EMT Mass Casualty Training Simulation. And so in here, we were able to, in a civilian realm, sort of confirm the mass casualty triage as a management problem with primary bottlenecks surrounding the continuous monitoring as well as the prioritization of these casualties. And with additional kind of feedback from our subject matter experts at the Stanford School of Medicine, we were able to solidify that really at this stage, with mass casualty triage being relevant, it is a waste of time to try and diagnose. The really situational awareness and kind of help that they need is the prioritization of casualties, such that the right people can get to the right treatment at the right time. And thus came our first MVP. Essentially, we proposed a predictive machine learning algorithm that ingests a set of vitals information from already FDA-approved biopatches such as Zephyr, and ingests this information in order to print out a priority queue of casualties based on severity and priority for treatment. And this would be accessed as an interface to the triage manager. And so essentially, this was a potential solution for automating pre-evacuation mass casualty triage. However, sorry, this is not our final slides. But essentially, we pivoted to MVP 1.1, which was a slightly different version of this MVP. Essentially, it still relied on the Zephyr biopatches, as we have in that picture, but instead of, we realized that in too far forward environments, with kind of this complexity of the human decision making at this stage, we were not able to best replace this human decision making, but at best augment it. And where we want to automate it is really the monitoring portion and not necessarily the prioritization portion. And so we would essentially, our second MVP that we presented as a mock-up was an automation solution based on input from these Zephyr biopatches. However, we testing with our with the people who really informed our problem statement of mass casualty triage as a management problem. These people were, as Abby mentioned, kind of pararescuemen, medics, line medics, who are very far forward in this operational care pathway. And they said that this level of situational awareness that we're trying to provide is really far too granular, and the time that you spend at this stage is really far too short to want to kind of push this technology and for it to have any value proposition at all. So with the help of one of our key mentors, Lieutenant Colonel Hasseltine, we went ahead and tried to, come out of this dip by literally reevaluating our facts and assumptions. And one of the primary assumptions that really guided the final development of our both the conceptualization as well as the product of our MVP was that during this mass casualty situations where medevacs are limited, it is fairly safe to assume that these casualties are going to be transported all to a Role 1 Battalion Aid Station treatment facility. And that essentially the first stage along this operational care pathway, along which this extensive triage and treatment and these decisions that they needed additional situational awareness help with was taking place was this Role 1. So we went on another round of beneficiary discovery process. And so we went to essentially the key medical and non-medical beneficiaries at this stage to kind of get a better picture of what the dynamics and what the primary pain points at the Role 1 Battalion Aid Station looks like. So just a brief overview, as we already mentioned in our video, the casualties would be incoming and received by a secondary triage officer, and with the help of medics kind of re-triaged and continuously monitored. And the most severe casualties would be essentially referred and taken inside the tent, where more senior medical officers, most commonly a physician's assistant and maybe an MD, would take care of intervention and any treatment that they can, and move these people either, basically provide the treatment and have prolonged field care, or move them to the next stage, Role 2 or Role 3 care by recommending evacuation to a tactical commander at this stage. And so we realized after learning more about the current practices of at the Battalion Aid Station, the current process, as well as kind of the infrastructure that they had, is that there was there was a need for a very dynamic chain of communication between all these different key players that we have in this previous slide. Basically, the medics, the triage medics that are outside the tent, the physician's assistant inside the tent who is providing both the treatment, monitoring the triage, and kind of the vitals of everyone who's being received, and recommending, at the very same time, evacuation decisions to a medical officer. And we learned from the beneficiaries that we were interviewing with direct deployment experience at this stage that this chain of communication that was critical to providing this level of care could very easily be disrupted in the case of a mass casualty, which is one of our key assumptions as part of our team in our forward-looking approach. And thus, Chris will tell you more about where we went from here.
Great. So looking at the BAS, wrong slides. Anyways, well, we move forward with the prototyping phase, with the ultimate goal of achieving the ever-elusive product mission fit. And we defined mission achievement in this context as saving lives where they're deemed preventable. You remember that stat that Abby showed you guys, 25% of all fatalities occurring before a medical treatment facility were deemed survivable, and we felt that by improving processes at the Battalion Aid Station, we could really reduce that number. So to that end, we developed two products that work in tandem with one another. The first is a mobile application that replaces the standard TCCC card. As you saw in the video, a triage officer can utilize that mobile application to record patient information as casualties arrive at the Battalion Aid Station. The second product is a web dashboard designed for the treatment phase. So medical personnel can utilize this dashboard to look up patient information, to track vitals information that's coming from the Zephyr sensors, and to track patient progress over time. And this is how we envision these products fitting in at the BAS. As I mentioned, the secondary triage officer utilizes the mobile application to input patient information. And inside the tent, medical personnel who are making treatment decisions, as well as deciding when and how to deploy medical resources, such as medevacs, can ingest that information in order to make better decisions with the limited time that they have. Armed with these new prototypes, we updated our mission model canvas accordingly, and in particular, the value props and beneficiaries. Most of this I've already described, but one important thing worth noting is that care providers at higher echelons of care could potentially benefit from this product if we are able to eventually transmit this information to Role 2 and Role 3 facilities. So we received some positive feedback on this MVP and found that oftentimes the sheer number of casualties really overwhelms the battalion aid station, and that improved situational awareness and active monitoring would have improved the outcome for the better. So armed with this confidence, we decided to move on to the development phase and start writing some code, which Andrew will take you through.
Yeah, so after confirming that a physician assistant would benefit from increased situational awareness within a battalion aid station during a mass casualty situation, we began development, and unfortunately, due to a lot of the pivots we had earlier, we started this week 9, so it's a pretty short time frame. So we began doing the triage officer application for recording patient info just on Xcode as an iOS application due to our familiarity with the platform. So we'd be able to develop it quicker, and it would make it easier for us to show it on our personal devices to protected beneficiaries. In parallel, we were developing the PA interface, which essentially is a web app, which is more universal and platform agnostic. And this is, as Chris described, what would be inside the tent and would be what is available to senior medical officers to allow them to make and inform evac decisions as well as just treatment decisions. So after developing these and getting them to a place where we thought they could be shown, Lieutenant Hasseltine was generous enough to set up a meeting with us in San Bruno at the 23rd Marine Regiment, where we showed and just pitched the MVP to projected beneficiaries who might be using this. We got great feedback, one of which is that the continuous monitoring and specifically would eliminate the time between patients, which is typically 15 minutes, but given that you have continuous vitals monitoring, this goes from 15 minutes to essentially whenever you want it. So this was one thing that was very encouraging. They also had a lot of other suggestions as far as adding more information, as well as incorporating missed card information, which we hadn't originally anticipated. So as far as next steps go, we're going to be continuing development, given that it's in a pretty rudimentary phase. We're still prototyping. We're still showing our lo-fi MVP to beneficiaries. And we envision this cycle of development and beneficiary feedback ongoing for the near future. As far as immediate next steps, once this code's in a place where we can, where we feel comfortable sharing it, we'd be happy to put it on GitHub, open source it, and allow for potential forks of this repo for more specific applications, whether it be in the civilian realm or in just more specific military applications. As far as going from here, we have not yet interfaced with the Zephyr sensors, so in order to do that, we'll have to acquire funding of some kind, either through an award or a grant like the AA MTI award. And we would need to do that to first interface with the Zephyr sensors. In addition, we would work with our sponsors at USAMA once we have our MVP in a place where we can begin drafting up a formal requirements document. And then once that's generated, we'd be able to sort of test on units that have more frequent deployment cycles so we could get a quicker feedback loop. So yeah, we'd just like to thank all of our sponsors from USAMA, Major Love, Jay Wang, a lot of other people. We'd like to thank Melissa, teaching team, Steve Hong, and all of you guys for this great opportunity.
information that local citizens have access to is controlled by local militant groups. It is important that these local citizens get access to accurate outside information. US military organizations, such as the 5th Special Forces Group, can also benefit from our accurate information about on-the-ground civilian activities in the denied areas. Based on the insights we got from the interviews and our understanding of the region, we came to an aerial-based solution to provide internet to the denied area. The key component of the system would include 3 modules. 1, the small cell 4G LTE unit to beam the internet to the ground. 2, the compact satellite communication unit to link to the internet. 3, the onboard server for cached content. The system can be mounted on existing drones, or the proposed solar medium altitude long endurance UAS with the endurance of 3 months. The commander has the full control to relocate or turn on and off the internet via the satellite link. Soaring at 6,000 feet, one system could cover up to 5 square kilometers and provide simultaneous connection to up to 400 people. The local population can post on Twitter or Facebook, as well as send out messages via the backhaul connection of satellite. They also have access to the cached content, including news, music, and movie, pre-selected and preloaded by the Special Forces or other trusted organizations.
We are Team Broadcom. The goal for our project is to provide internet to denied areas such as Syria and Iraq. Currently, local citizens on the ground have limited access to the internet, and when they have access to the internet, their usage is censored or heavily monitored by local militant groups such as ISIS. At the same time, our sponsor, the 5th Special Forces Group, has limited knowledge of what's happening on a day-to-day basis in the denied areas. By providing internet to the denied areas, our sponsor, the 5th Special Forces Group, can monitor the usage of the internet and get a lot more information about what's happening on a day-to-day basis on the ground. During this presentation, we will explain our journey in hacking for defense and explain how we went from week 1 to week 9. Our team consists of Ital, a PhD student in mechanical engineering with expertise in drone technology, Fabian, an economist with expertise in information technology, and myself with a background in computer science and electrical engineering. During this course, we interviewed 118 experts, ranging from ODAs, operational deployment alphas, in Syria who served in Iraq, journalists who have been in Syria and Iraq, Syrian and Iraqi citizens, and domain experts. Initially, we started out with a drone-based solution powered by solar panels that could fly over the region and provide internet during limited periods of time to those citizens in the denied areas. We ended up with a much more specific solution based on our interviews and our understanding of the demands of the sponsor and the local citizens. This is an overview of our emotional state over the course to give you a better understanding of what we went through throughout the course. It took us a long time to get started. Our team wasn't formed in week 1 yet, and we only had 2 team members, Ital and Fabian. In addition, we had no clue what we were doing, and we had no strategy yet in week 1. Then we quickly assembled a team. We had 2 domain experts, Ital and Vera, with expertise in telecommunications and drone technology. And we jumped to a solution. We started brainstorming, and after about 5 minutes, we thought we had the solution.
So we think we're back on track. We have 22 interviews. We've caught up with everybody else. And that week, we started our presentation. And it was the start of the Chaos Valley. So 5 minutes into the presentation, we are heavily questioned on our assumptions. We are questioned as to who is going to treat the information, who is going to pilot the drone, and we find that we are incapable of answering those questions. I'm ashamed to say that we don't even, at that point in time, know what ODA means. So, lesson number 1, know your beneficiaries. In depth. So we go back to the drawing board with that. And so we hypothesized that the ODAs needed a communication platform in those denied areas to be able to communicate with the local population. With that in mind, we approached Colonel Leahy, commander of the Special Forces Group out in Turkey. And very quickly, he tells us that he doesn't want another gadget, telecommunication gadget, for his soldiers. All he wants was to provide internet to the local people in the denied areas. That simple. In addition, through all the interviews that we had done at the time, we were directed towards a video that provided us with a lot of insights. It kind of explained us what it is to be a special forces soldier out there in the field, and kind of understanding what they're doing on a day-to-day basis. And so it kind of helped us in getting to that aha moment. And we came to the conclusion that what it's all about is really about winning the hearts and minds of the people. And the solution that we were trying to build was a solution that was adding to all the tools that they have out there, in addition to, for instance, medical treatments or food supplies. This was another way of helping the local people. And so, though we had heard over our interviews this statement being repeated, we had never really understood it until that video. And so it changed a little bit our mindset in determining that we had on one side the 5th Special Forces Group as our primary beneficiary, but we also had on the other side, again, another primary beneficiary being the civilians. And so the 5th Special Forces Group, what they wanted was to have a tool to provide unbiased information to the local population. They also wanted a tool to know what the local citizens are thinking, to collect information as to what's going on, and to communicate with the local population on a need basis. And so on the other side, the local civilians wanted to have access also to unbiased information, but also potentially to entertainment, and to have access to perhaps families that are living outside of the denied zones.
So with the confirmed beneficiary and what the value proposition to them, we start to look at the whole space, see what kind of the telecommunication solution we could have to provide internet to the denied areas. We come to 4 potential solutions. The first, a simple mesh network, direct communication between 2 cell phones. And we're also looking at, can we build a cell phone towers on the border of the denied areas and beaming internet directly to the denied areas. Or maybe put it on the truck, so when some threat comes, you can move around it. And the last part we're looking at is actually putting the communication payload on a drone, flying directly into the denied areas, providing internet to the local civilians directly. So then we conduct more interviews, actually talking to experts have experience on operation on the fields. And we come to a conclusion that put the payload on the aero platform is the most feasible ways to provide internet. We recommend this solution to our sponsor, and we receive a very strong positive feedback. So he said we are talking. So that's great. So since we got this kind of very first positive feedback we got, and we started to look at a little bit in details how we should build the MVP and what kind of the exact payload we want to put on the drones. So let me introduce a little bit about the MVP. So it includes three major parts. The first is small cell solutions providing 3G or 4G networks to the people on the ground. On the back, it has a satellite communication, backhaul communication to connect to the global internet. So the local people could using that connections to post on Facebook, post on Twitter, send WhatsApp, send emails. The third part of the system is the onboard servers, which store lots of pre-loaded and cached materials, including news, including music, movie, and other forms of entertainment. So people can have access to those content without using the very limited bandwidth of the satellites. So all these three parts I mentioned is commercially available. You could buy it from today from the market, and the total system cost will be under $100,000. And this system is also very lightweight and compact, so we could mount it on the existing drones. But we are also working with a local startup who are building a solar, medium-altitude, long-endurance UAV so that we can actually extend the mission up to 3 months without the need of the landing. So everything is on track until we have some bad news. First bad news, one of the team members left us. But the other bad news is actually, oh, sorry, my bad. So actually, if you look at the matrix, we think there's the three major matrix that would be very important to measure the successful of the mission. The first is the number of the users and the length of communication we would have. The second is actually the number of the Facebook and Twitter posts the people generate through our service. And that's a good way to measure how much intelligence could be generated. And the third part is the number of the downloads of the content so that we can measure the effectiveness of the propaganda materials. So well, I already gave a little bit sneak peek of what happened next. So unfortunately, a team member left, and we also get challenged from both of the teaching team and the sponsor, how would you operate that? So to answer that, we actually developed the concept of operations to explain from how would you deploy the drones, who will operate it, and how would you recover it. I'm not going to cover too much information here, but when we pack everything, the design of the MVP and the mission, the concept of operations, and we push it to our sponsors, we actually got very good feedback. This is a quote from Colonel Leahy, and said, could we use many of them together? And so why not fly 20 of them over the target areas? The concept looks great. And besides that, we also think we can actually find a dual-use applications. So if we can replace the 4G LTE payload with a similar weight camera payload, now we're talking about solutions, low-cost alternatives for persistent ISR or intelligence surveillance and reconnaissance. And that's a hot topic for lots of DoD organizations as well as for DHS. Also, the similar system could be used as the first responders to rebuild the telecommunication in the disaster relief situations. So if we look at the IRL, all of the components are from commercial suppliers. So for us, it's really just to integrate them and mount them on the existing platforms. So we consider ourselves have a relatively high internal readiness levels. And at this moment, I would like to thank the 5th Special Force Groups to provide us all the information, the military liaison to give us the different perspective of the problems, teaching team, especially Isaac, give us lots of guidance, and our mentor, Craig. And the last special thanks to the whole DoD and intelligence community at Stanford. I personally am really shocked to see how many members there are and the amount of insight they provide us to these projects. That brings end to the conversation. Again, we're Broadcom. We are providing the internet service to the denied areas. Thank you.